In this lecture, we will write counting on two 7 segments. This will write from 0 to 99. Let's just develop the hardware, but save it with some other name because it is a different hardware. Let's name it 2 7 segments. Place the 7 segment here and connect it to port C. In the similar manner, we connected it to port D. And connect the common to ground. Hardware is complete. Now let's design software. For this, first we will see its mechanism. Suppose these are our two 7 segments. If we want to write 25 on it, we will have to break 25. 5 will be sent here and 2 on the left 7 segment. To break it, we divide it by 10. 2 is called quotient and 5 is called remainder. So we will extract remainder and quotient and we will send it on the segments. Let's take another example. Suppose we want to send 56. So we will divide 56 by 10. It will separate 5 and 6. This is called quotient and this is called remainder. We will send quotient to the left segment and remainder to the right segment. Okay. In the program, we define 3 variables. First will be I, dim I as byte. It will reserve a space of 1 byte in RAM like this. This is reserved byte and its name is I. Now define another variable Q to store quotient. It will reserve another byte. Similarly, we will define a variable for remainder, dim R as byte, and another byte will be reserved named R. Now suppose I write I equals 25. It will store 25 in I. If I divide 25 by 10, it will store quotient in Q. This two will go to Q. Okay, now we are going to see a new operator. This is called remainder operator. It will divide 25 by 10 and it will store the remainder in R. That's why it is called remainder operator. In this way, we can separate quotient and remainder. Now let's design software. First, save it. Name it 2-digit counting. You can define variables. Dim Q as byte and dim R as byte. Okay, now for I 0 to 99. Next. Q equals I by 10. And then R equals I remainder 10. So hence we will extract quotient and remainder of each number. Then port D, As our 7th segment is connected to port D, our left 7th segment, so we will send quotient to port D, A, Q, and remainder to port C, because right 7th segment is connected to port C. So A, R. After that, let's provide a delay 333, compile. Import the new hex file, 2-digit counting. Let's run it. Oh, it's not working. The right 7th segment is not working. Reason is that we didn't declare port C as output. Let's declare his output and it will work fine. Output port D. Output port C. Compile and run. And yes, it is working fine now. It will count up to 99. If you liked the lecture, scroll down a bit, subscribe, ring the bell, comment. You can like it, you can dislike it too. And if you think this video can help someone else, you can share it on your WhatsApp, Twitter, Facebook, etc. Thanks for watching.